Swayam Prabha. Digital India. Educated India.
Welcome back. So, in the last lecture we have seen Venn shear test and two important characteristics, that is sensitivity and the thixotropy of soil. So, today we will be talking about the Skempton pore pressure parameters determination. Already you know what are different pore pressure parameters, that is A and B, capital A and capital B. We introduced that thing when we were talking about the different laboratory triaxial test. Okay. So, anyway, now we will be seeing in more detail how these pore pressure parameters can be developed or can be found out. Okay. So, pore pressure parameters are empirical coefficients, right, which are used to express the response of pore pressure to change in total stress under undrained condition. Okay. So, this pore pressure parameter will basically help you to find out the pore change in to get the total pore water pressure because of some change or the variation in the stress under undrained condition, because if it is not undrained condition you will not be getting the pore water pressure. If it is a drained condition, then complete water will be draining out and there will be no pore pressure development, right. So, this thing is only valid when you are talking about the undrained situation. Okay. So, now consider an element. Now, we are trying to develop from the basics means from the mechanics point of view. So, consider an element of soil which is elastic, okay, and isotropic, okay, acted upon by compressive principal stress increments sigma 1 prime, sigma 2 prime and sigma 3 prime. So, delta sigma 1 prime. So, this is the stress increment. So, delta sigma 1 prime, delta sigma 2 prime, delta sigma 3 prime on the applied stress, say this is the stress increment we are applying. Now, what are these components? So, sigma 1 prime, delta sigma 1 prime is nothing but the stress increment, that is the measure principal stress increment, okay, effective measure principal stress increment. Then delta sigma 2 prime is the measure intermediate principal stress increment and delta sigma 3 prime is the minor principal stress increment. Okay. So, we are considering all the principal stresses, major, intermediate and minor. Now, under this application of the stress increment, you will be getting some volume reduction, that is nothing but the volumetric strain. So, the soil element decreases in volume because of the application of the stress increment, effective stress increment, and that volumetric strain is given by delta V by V, where delta V is the volume change and capital V is the original volume. Okay. So, that is nothing but epsilon V. Now, if epsilon 1, epsilon 2 and epsilon 3 are strains in the directions of the three principal stresses. Okay. Now, epsilon 1 is along major principal stress direction, epsilon 2 is along intermediate principal stress direction and epsilon 3 is along minor principal stress direction. So, we can express all the strain components like epsilon 1, epsilon 2 and epsilon 3 by using the Hooke's law, like this: epsilon 1 is equal to 1 by E into delta sigma 1 prime minus nu into, where nu is the Poisson ratio, into delta sigma 2 prime plus delta sigma 3 prime. Similarly, I can express epsilon 2 and epsilon 3, right. Okay. Now, what is your volumetric strain? So, from the mechanics, if you recall your mechanics background, so delta V by V is the volumetric strain, which is nothing but equal to epsilon 1 plus epsilon 2 plus epsilon 3, exactly, right. So, which is equal to, from the previous expression, so previous expressions we can express this delta V by V, that is the volumetric strain, is equal to 1 minus 2 nu divided by E into delta sigma 1 prime plus delta sigma 2 prime plus delta sigma 3 prime, okay, which can be further written that, I mean some modification or some modification, change we are making, that is delta V by V, again we are multiplying 3 here and we are dividing this whole thing by 3. Okay. So, which is nothing but delta V by V into 3 by the summation of all stress components is equal to 3 into 1 minus 2 nu divided by E, which is known as, and which we are expressing as Cv, which is nothing but the compressibility of the soil skeleton. Okay. Now, what is this? This left hand side, if you look at the left hand side, what is this? So, in equation 5.48 means that the ratio of epsilon V to the average effective stress change. So, this is nothing but the average effective stress change, right. So, whatever sigma 1 prime, whatever changes are made, so this is the average of that. So, all 3 stress components divided by 3. Okay. So, this the ratio of these two, that is epsilon V, the ratio of epsilon V to the average effective stress is a constant and is equal to 3 into 1 minus 2 nu divided by E, right. This is a constant, all the times it will be constant. So, whatever volumetric strain you are getting and whatever average effective stress is there, the ratio will be always constant. And for a perfectly elastic material, okay, so Cv is called compressibility of the soil skeleton. Okay. Is that clear? So, this Cv is basically a, I mean if you look at this, Cv is a constant kind of thing. So, now in the next slide basically will be, now let delta U be the increase in pore water pressure when no drainage is allowed. Okay. So, delta sigma 1 prime is equal to delta sigma 1 minus delta U, total stress minus pore water pressure. Similarly, I can express delta sigma 2 prime and delta sigma 3 prime. The total stress minus the pore water pressure which is getting developed is giving you the effective stress. So, delta V from the previous expression I can write V into Cv into the delta sigma 1 prime plus delta sigma, I mean basically this is nothing but delta sigma 1 prime plus delta sigma 2 prime plus delta sigma 3 prime, right. So, now in terms of total stress parameters, delta sigma 1 plus delta sigma 2 plus delta sigma 3 minus 3 delta U, that is the pore water pressure, which will be giving me the volume change, that is the delta V. So, now the change in volume of pore fluid, try to understand. So, we are coming from the basics. Now, the change in volume of pore fluid, that is water plus air. So, pore fluid means it is made of water and air, the mix of that, right. So, now the change in volume of pore fluid delta VW due to increase in pore pressure delta U must be equal to the volume change given in equation, because only the pore fluid can experience the volume change. I mean the soil grains, that solid materials or the solid grains of the soil, they will not be experiencing any volume change. So, whatever volume change is happening due to the increase in pore water pressure, that is solely due to the volume change in the pore fluid, right. So, delta VW, if it is the volume change in the pore fluid, that must be equal to delta V, right. So, if N is the porosity and Cw is the compressibility of the pore fluid, then I can write delta VW, that is the volume change in the pore fluid, is equal to N into V into Cw, and that is happening due to the pore water pressure delta U. I can write that. So, from the basic principle or the basic mechanics knowledge or the concept, right. So, again just now I have told you that delta V, that is the change in volume, change in total volume, must be equal to the change in pore fluid, I mean volume of pore fluid, right. So, because soil grains will not be experiencing any volume change. So, therefore, Cv into whatever you have seen in the previous expression, Cv into this is equal to NCW into delta U. So, from this expression I am getting this, and from the previous expression I have got this. So, in the conventional triaxial stress, now this is the relation we have established, agreed. We have established the relation Cv into delta sigma 1 plus delta sigma 2 plus delta sigma 3 minus 3 into delta U divided by 3 is equal to N into Cw into delta U. This is the general relation. Now, in the conventional triaxial test already you have seen, now if you recall, we have applied the all round cell pressure, where your delta sigma 2 was equal to delta sigma 3. That means, there was no concept of intermediate principal stress, rather intermediate principal stress and minor principal stress, they became same, right, when we talked about the triaxial test. So, if that is so, then delta u can be expressed like this from the previous expression, which can be further written as this, okay, delta sigma 1 minus delta sigma 3 plus 3 into some modification we are doing, which can be further written as this, what, delta u is equal to, that is the pore water pressure increment is equal to this. Now, if you look at this expression here, this is the part and this is the whole part, okay. Now, it can be written, this expression can be written in this fashion, that is delta u is equal to b into delta sigma plus a into delta sigma 1 minus delta sigma 3. Now, we are expressing these two, I mean this expression or this equation by this expression given in equation 5.51. Now, from this, where then B and A are called as Kempton pore pressure parameters. So, now I hope that you have understood that how these two parameters are coming into the picture from the basic principle of mechanics. Okay. So, earlier we introduced that Kempton pore pressure parameters, at that time we never talked about how these parameters are coming into the picture, but now you are quite clear how these parameters are coming into the picture, right, that these B and A. So, it can be written as that if you see the previous expression, right, if you see the previous expression equation 5.51. So, basically I can write delta u1 is equal to b into delta sigma 3 and delta u2 is equal to ba into delta sigma 1 minus delta sigma 3, right. So, total pore water pressure increment is equal to delta u1 plus delta u2. Now, if you recall, when we talked about the triaxial test, at that time we introduced A parameter as well as B parameter in different, I mean A parameter and AB parameter, multiplication of B and A, okay, or this B parameter and this multiplication of B and A in different conditions or different situations, right. So, this delta, what is delta u1? Delta u1 is the change in pore water pressure due to an increase in cell pressure delta sigma 3, okay. So, as you increase delta sigma 3, you are getting delta u1, that is the change in pore water pressure. So, delta u2 is the change in pore water pressure due to an increase in the deviatoric stress or the deviatoric pressure, that is delta sigma 1 minus delta sigma 3, okay. And combined effect will be giving you the total pore pressure increment, that is delta u. So, delta u1 is happening in the first stage, delta u2 is happening in the second stage of the triaxial test, and the combination of these two will give you the total pore water pressure increment. Now, for completely saturated soil, only pore fluid is water, agreed, and compressibility of water Cw is very less than Cv, that is the complete volume, I mean soil skeleton, volume compressibility of soil skeleton, right. Therefore, I can write Cw by Cv is approximately equal to 0, because Cw is very less than, because water is water is incompressible, right, only the pore fluid is water in case of saturated soil, right. So, if the water is completely incompressible, then I can write Cw by Cv is approximately equal to 0, and which will give me B equal to 1. If you just see the previous expressions, the B equal to 1. In a dry soil, the compressibility of the pore fluid. So, in the dry soil, what is your pore fluid? Only air, there is no water. So, air is highly compressible. So, Cw is very greater than Cv. If that is so, then Cw by Cv I can say that is infinite, okay, very high value, infinite value. So, B becomes 0. So, B basically varies from 0 to 1. So, B varies from 0 to 1 depending on the degree of saturation S. So, as it is completely saturated, B will become 1, as it is becoming completely dry, that means degree of saturation is 0, at that time B becomes 0, right. So, B becomes B varies from 0 to 1 depending on the degree of saturation. Now, if B is 1, that means the degree of saturation is 100%, that means the pore fluid is completely made of water or filled with water. So, there is no air. So, in that situation delta U, so B is 1, so delta sigma 3 plus A into delta sigma 1 minus delta sigma 3. So, basically what I mean to say, if you consider 100% saturated soil, okay, in the triaxial test, if you know the value of A and if you know the increment of sigma 1, increment of sigma 3, you can find out the pore pressure, how much pore pressure is getting generated during the test at different stage. Now, for a partially saturated soil, delta U is given by this expression, where A bar is nothing but the multiplication of A into B. Now, B can be determined in an unconsolidated undrained test, right. B can be determined in an unconsolidated undrained test. The cell pressure is increased by delta sigma 3 and the corresponding increase in pore pressure delta U1 is measured in the first stage, then B is given by this. That means, if you measure delta U1, right. So, you are doing some unconsolidated undrained test, that means in the first stage also you are closing the valve, in the second stage also you are closing the valve. So, in both the stages you are measuring the pore water pressure. So, in the first stage, so B is given by this expression, right, B is nothing but delta U1 by delta sigma 3. Now, in the first stage, when you are applying only the cell pressure and you are not allowing the consolidation of the soil sample, so basically some pore water pressure will be getting built up. So, that pore water pressure is nothing but delta U1. So, delta U1 by delta sigma 3, that is the increment of cell pressure, will give you the value of B. So, in that way B can be calculated or B can be determined. Now, A bar is measured during the second stage of the triaxial test. So, in the undrained unconsolidated undrained test you are performing. So, A bar is measured in the second stage of triaxial test. Second stage means when you are applying the David-Rick stress. So, if delta U2 is the pore water pressure increases due to delta sigma 1 minus delta sigma 3, that is the David-Rick stress, right, with cell pressure being constant, cell pressure is constant, that means delta sigma 3 is 0, then A bar is given by this, agreed. So, A bar is given by this. So, for a fully saturated soil, A can be determined easily in consolidated undrained test. Okay. So, B you have determined and A you need to determine. So, A for a fully saturated soil, A can be determined easily in consolidated undrained test. So, the first stage is not required. Consolidated undrained means in the first stage you are allowing drainage. So, therefore, delta U1 is 0. So, only you are measuring delta U2. So, that is only required. So, to find out A. So, once you obtain B and then you do consolidated undrained test to find out the magnitude of A, okay, because you need delta U2 only. So, in this test delta sigma 3 is 0. What is that? Consolidated undrained test, delta sigma 3 is 0. So, A is nothing but this. So, delta U divided by delta sigma 1. So, what is delta U in this consolidated undrained test? Because delta U1 is 0, that is nothing but delta U2. So, delta U2 is nothing but your delta U. Okay. So, from this you can find out A. So, you measure this, you know sigma 1, you know sigma 3, you can find out A. So, A depends upon the strain, anisotropy, sample disturbance and OCR. So, these are the parameters which will govern or which will affect the magnitude of A. What are those things? Strain, right, anisotropy, that is how much strain is happening in the soil sample, anisotropy, if any anisotropy is present in the soil or not, sample disturbance, so how much disturbance is happening in the sample, and of course, the over consolidation ratio, that is OCR. So, these are the things will affect A. So, now I hope that this is clear to you that how we can find out these two parameters by performing the triaxial test. So, if you want to know the magnitude of A, basically you perform consolidated undrained test and you get these things from the test and you get the parameter A, and if you want to find out the parameter B, then you obtain or you perform some unconsolidated undrained test, and from there you can find out B. So, these two parameters already we have seen that how we can establish these parameters, how these parameters have come into the picture, and how we can find out these parameters from the laboratory experiment, laboratory triaxial test. So, I will stop here today, and this will conclude the shear strength chapter. This chapter was quite big, and I took little bit more time so that you understand this concept, because this is very important chapter in the soil mechanics. Everything, all the design aspects, all the design philosophy in the geotechnical engineering is lying or is based on this shear strength. So, I will stop here today. Thank you very much. So, next class we will take some numerical examples on shear strength. Thank you.